So pressure versus force. When we talk about pressure, pressure is always going to be the same at the same height. And this is in a static fluid. So when it's not moving, the pressure is the same at the same depth in the liquid. Now, one thing to think about here is you could be in a pool and swimming in a pool. Here's you swimming in the pool. And you could be at a certain depth. And it doesn't matter if you're in a pool or in a really huge lake. Either way, if you are at the same depth, you are going to feel the same amount of pressure, which makes sense. If I dive down 5 feet underwater in a pool, or I dive down 5 feet in a lake, I will feel the same pressure on my ears and on my head. Force is a little bit different. Force is going to be how hard you push on the liquid. So when we talk about pressure, it's how hard you push per unit area. So pressure is force divided by area. So in this picture here, these are showing that the pressure is the same at the bottom for all of these. It does not matter how wide it is. It does not matter the shape. The only thing that matters for pressure is the depth of the liquid when the fluid is not moving. And then we have this practice problem where our granny is going to push on a needle or on a thimble. And you can calculate the pressure depending on the size of the area that you're pushing on. So you apply the same force, and the pressure on your finger is going to be different because of the area that you're pushing on. So for part A, the radius of the needle is 0.05 millimeters, and we want to find the pressure. And in part B, the radius of the thimble is 1 centimeter, and we're going to figure out the pressure. So remembering pressure is just force over area. We have to make sure that our area is in meters. So I started here with the radius being 0.05 millimeters, and I converted that to meters. And then I put that into the equation for the area of a circle. And so that's pi r squared, where my radius is this. I like to use capital R for radius, so it does not look like a V for velocity. And then I went ahead and put that in my calculator. So this is that area, and solve for pressure, which is 101,859,163, depending on the sig figs that you're using for pi, which rounds to 1.02 times 10 to the 8 pascals. And then for part 2, I went ahead and figured out the radius in meters again, but now it's for 1 centimeter, which is 0.01 meters. And I plug that in and I get a pressure of 3.14 times 10 to the negative 4 pascals.